Assalamu alaikum, my dear students. I hope you all are well. I'm your teacher, Ms. Adika, science teacher. This video is basically an extension of the previous video I have uploaded of the basic terminologies of kinematics. In this video, I will help you out that how can you solve the worksheet I have given to you. The worksheet I have opened right now is for 8O class. There are some links which could be useful for you guys. One more thing, that if you will read before solving this worksheet from page number 16 to page number 25 from your book of O levels in unit number 2, it would be really easier for you to solve it. So let's look at page number 16, what's happening. So on page 16, main learning outcomes of this chapters are present, and the main learning outcomes are not all in all we are going to learn. As you all know that you are in 8th class, so you will have an introductory session of it. Basically, speed, velocity and acceleration are the terms, are those jargons which are widely used in the field of kinematics. And what is kinematics? In the field of physics, the study, or you can say the description of the moving body, the description of the motion of the body is known as is studied under the terminology of kinematics. So let's see that there are many learning outcomes. The first is about that we will state what is meant by speed and velocity, and the second one is that we will learn about the uniform acceleration. We will calculate acceleration as well, velocity per time. We will interpret the examples of non-uniform acceleration as well. We'll calculate the speed using distance traveled per time, and we'll plot and interpret a distance time graph and a speed time graph. These are the main things we have to learn. So the first question number 1 has got 4 definitions about displacement, speed, velocity and acceleration. So on page number 17, unit 2, you can see in the key idea that what is displacement. On the right side at the top, the displacement is the distance moved in a specified direction. This is on and all you have to write over here, and same goes with everything. I have already given the idea of distance and displacement in the first trimester when we were doing physical units in the scalar and vector quantities. So I hope you will write the definitions of speed, velocity and acceleration in it, and you will learn it. And for more information, you can Google the links I have provided to you. In the second question, you are going to differentiate between distance and displacement. The first difference you can write is about the scalar and vector quantities, and then you can write the definition. You can even write the examples I taught you. In the third question, you are going to write the formula of speed, velocity and acceleration. From where you will get it. On page 17, the formula of speed, velocity is present on heading 2.2, and you will search the acceleration formula by yourself, and I hope you will find it soon because I have already guided you. On question number 4, I have asked that what do you mean by initial and final velocity. When we're talking about initial and final velocity, so it is I hope that it would be a bit easier for you guys that when do we use the word initial and when do we use the word final. So if we are adding anything along with it, either it is a velocity, acceleration, speed, distance, so you can understand it as well. And if you remember that I have given the example that if we are traveling from Frobels to Gulshan Chaurangi, so the Frobels could be the point from where you have initiated, and the Gulshan Chaurangi could be the point which can be taken as the final one. So now you know that how to define it. As far as concerned with the book, so in the book, whenever they talk about the total distance covered, so you obviously have to look from the initial distance and from the final distance. It is basically the distance which is being covered, and you can read worked example on page 17 2.1. A car travels 5 km due east and makes a U-turn back to the travel a further distance of 3 km. So you will learn the distance total the car has traveled from the starting point and from the ending point. Starting is the initial one and ending is the final one. And you will learn about the displacement as well. Displacement is just the change of the position, while distance is the total quantity of the magnitude the car has covered. The fifth question is about the explanation of the distance time graph. Read figure 2.6, write points. Deductions are already present along with the figure on page 20. So let's see figure 2.6 when we're talking about the displacement time graph. When we talk about the displacement time graph, you all know that the displacement time graph is basically a graphical representation of something. As I have already told you that it is a graphical representation of physical quantity, which is displacement and time. If we are talking about displacement and time, so we can consider a car traveling along a straight line with its displacement from the starting point represented by S. On page 20, the first picture of a car from the starting point towards the ending point can help you out in solving this. Another hint that you can read all the deductions which are present along with figure 2.6. The following deductions can be made, so it can help you out also in solving this graph and understanding this graph, that what is being said. Okay, on which axis what is present? Do you remember that I talked about the dependent and independent variable? It is a hint. Another hint is there that from the units you can see that what values, what physical quantities are being taken. Can you please see that on x-axis it's time, t upon s, and on y-axis it's s upon m. S is representing displacement, m is presenting meter. Displacement has the unit m. Now you know what is it. And time has the unit s. So what is s? Is it a minute or a second? Think about it and make points to explain it when we'll talk about it. So we'll discuss it more. Okay, so these are the hints I have given to you, the speed and time graphs. Now this graph is really important. It is telling basically that how we will study that at what time what was the speed, how things accelerated. So do you remember that when we were learning about the physical change of physical states of matter, so when the line is basically horizontal, there is an equilibrium in a physical state of matter. So when we're talking that line is horizontal, it's basically the constant speed. That speed is not changing. Car is moving, but speed is not changing. Or you can say it is covering the distance in a uniformity. When it is deceleration, so the acceleration is decreasing, and when it's accelerating, so the acceleration is increasing. So basically, what is acceleration? Can anyone? Okay, I forgot that we're in a very talk. So I know that you will read from the book, but as far as it is concerned with the video, I will only read it, the definition, and I will share with you that acceleration is the rate of change of velocity. And now I need to know what is velocity. It is the rate of change of displacement. So if it is increasing, it's accelerating. If it is decreasing, it's deceleration. And if it is a uniform speed, it's a constant speed, and the graph will have the horizontal line. The next question is about the velocity time graphs, and you have to make points about it from page number 25. All in all, you have to do it by yourself, but still I can help you out in it. From these graphs, you can make points of first, second, and third one. In the first one, the body is at rest. Like there is no velocity, obviously, no distance is being covered. Okay, on page 25, the second graph is showing that object is moving at a constant speed. This graph is clearly showing that time is increasing, distance is being covered too, but because of the velocity, it has got uniformity in it. It is not changing. but the body is moving, the object is moving. The third graph is showing that object is moving as well, but it is also accelerating. So change of velocity does not mean it's only changing. If it is increasing, the graph will obviously move towards the upward direction. But if the body is moving, it will move upward, and it is called as the positive gradient. The body or the object acceleration means that the gradient is basically positive. Now, what is the gradient? Gradient of a displacement in any time graph shows that the velocity of the moving object. If it is moving in a positive way, it's accelerating, so definitely the graph will move upward, and with deceleration, it's vice versa. These graphs are really important, and you can be asked to write points about it and explain it on board. Question number 7 is actually overlapping of the fourth question. We can change it from initial and final distance. So think and write that what could be the initial and final distance. Question 8, 9, 10, 11 are totally up to you from Google, and from your mind you have to think about it. On question 12, there is an example on page 17. You have to think about it and write some points, that how the body has covered the distance and what could be the distance and displacement, and we'll be discussing in the class. If the student, if you want to record it, that you wanted to explain the word example 2.1 from page 17, you can make a video too, as I am making, and you can share too. In the last question, the second last one, from any toy car from your home, you have to make a displacement time graph. You have to take that toy car and you have to have a scale of that distance you think that your car can cover. Assume first, or before assuming, take some long scale too. After that, have a stopwatch with you and count the seconds from 0 till 60 and make the gradient on the graph. Last question is about the previous second trimester topics we have done with the chemistry. In A2 we have deeply studied a few topics like kinetic particle theory of solid, liquids and gases, convergent states of matter, along with the sublimation, and a few definitions we have done with the practicals as well, like diffusion, effusion, Boyle's and Charles' law, in which we talked about volume, pressure and temperature. That what happens when volume increases, what happens when pressure and temperature increases or decreases. We have done the practicals of melting and boiling points as well, and dynamic equilibrium as well. Go through all those definitions, make points, and then we'll discuss it inshallah when we'll get back.